So now in continuation, we will do some more questions based on atoms and molecules, right? Question number 5, as you can see here. Find the ratio by mass of the combining elements in the following compounds. First is CaCO3. What is CaCO3? That is calcium carbonate, right? And we have to find the ratio by mass. Okay, so how to do this? CaCO3 for the first one, right? So first we will write down what are the combining elements for this compound, right? So what are the combining elements here? Just look at this formula. Ca is calcium, right? Then C is carbon, and then O is oxygen, right? So these are the three elements which are combined to form CaCO3. Getting that? Okay. Now we will write down their masses, right? Calcium atomic mass is 40, and there is only one atom of calcium, right? Okay. So we will write it here 40. Then carbon, there is only one atom of carbon also, and its atomic mass is 12. So we'll write down 12 here. And oxygen is the right O3. We are writing O3. That means there are 3 atoms of oxygen in calcium carbonate, right? CaCO3. Getting it? So we will multiply the mass, atomic mass of the oxygen with 3, because there are 3 atoms of oxygen, right? So this will be 3 into 16, right? That is 40 is to 12 is to 48, right? Now, since this ratio is not in the simplest form, right? So we will find out the convert it into the simplest form or the lowest form by dividing all of them with 4, right? 4 is the common factor. Getting that? So we'll divide 40 with 4, it is 10. Divide 12 with 4, it is 3. And divide 48 with 4, it is 12. Getting that? So what is the ratio by mass of the combining elements calcium, carbon, and oxygen for calcium carbonate, CaCO3? It is 10 is to 3 is to 12. So in this way, you can find out ratio by mass. I hope you have understood. Yes or no? Please tell me. Right. So for the B part, H2SO4, that is the sulphuric acid, we will find out the ratio by mass, right? So first we will write down what are the combining elements here. So here the combining element are H, hydrogen, right? Then sulfur, hydrogen, sulfur, and oxygen, right? So these are the 3 types of elements, right? S and O, right? Now we will write down their total masses, right? So if you can see here, there are 2 atoms of hydrogen, right? And atomic mass of hydrogen is 1. So we will write here 2 into 1, right? Okay. So atomic mass of each hydrogen atom is 1, and there are 2 atoms. So we'll multiply with 2. Now for sulfur, there is only 1 atom of sulfur, right? And atomic mass of sulfur is 32, right? And again for oxygen, as we already know, atomic mass of oxygen is 16. But there are 4 atoms of oxygen here in this compound, right? So we'll multiply with 4. 4 into 16, right? In this way, you will get 2 is to 32 is to 64. Now, since this is not in the simplified ratio form, right? So we will find out the common factor which can divide all the 3. So 2 is the common factor, and that's how you will get 1 is to 16 is to 32, right? So the ratio of the combining elements in H2SO4, H ratio, S ratio, O is 1 is to 16 is to 32. This is your answer. Is that clear? Now look at the third part. We have to find out the ratio of mass, ratio by mass of the combining element for this C2H5OH. Now, first we'll write down what are the combining elements. So here we have carbon, hydrogen, and oxygen, right? So write it down. C ratio H ratio O. Right? Now we will count the number of atoms for each type of element. So there are 2 carbon atoms, right? 2 into, now atomic mass of carbon is 12, so 2 into 12, right? Hydrogen atoms, how many hydrogen atoms are there? 5 are this and 1 is this. So total 6 hydrogen atoms are there, and each hydrogen atom having a mass of 1 AMU, right? So 6 into 1. And oxygen, only 1 atom of oxygen is there, right? So it is 16. Is that clear? Right? Now this will become 24 is to 6 is to 16. Now we can convert this into the simplified ratio, right? Divide all of them with 2. So this is 12, 3, and 8. Okay. So what will be the ratio by mass of the combining elements in C2H5OH? That is 12 is to 3 is to 8, right? Now, similarly, we can find out for the next one, the D part, that is calcium hydroxide, CaOH whole twice, right? Now, again, we will write down the combining elements, Ca, calcium, oxygen, and hydrogen, right? Calcium, oxygen, and hydrogen, right? Three types of elements are there which are combined to form this, right? Now, we will write down, first, we'll find out number of atoms. So, calcium, there is only one atom of calcium here, right? Atomic mass of calcium is 40, so it will be 40. Now for oxygen, how many oxygen atoms are there? OH whole twice, right? So that means there are two oxygen atoms which are there, right? Okay. So atomic mass of oxygen is 16. So we multiply with 2, right? So this will become 2 into 16. Now hydrogen atoms, again, because this is the OH whole twice, right? Okay. So hydrogen atoms are also 2, right? Number of atoms of hydrogen in this compound is 2. So therefore 2 into atomic mass of hydrogen, that is 1. 2 into 1, right? So this is equal to 40 ratio 32 ratio 2. Again, we will convert this into the simplified form, divide all of them with 2. So it will become 20 is to 16 is to 1. And this is the answer. This is the ratio by mass of the combining elements in calcium hydroxide, right? So in this way, we can find out the ratio by mass for any compound. Is that clear? Yes or no? Now look at this another question, question number 6. An element X, we don't know what is X, okay? An element X has a valency of 2. The valency of this element X is 2. Now we have to find out the chemical formula for bromide of this element and oxide of this element, right? If we are forming the bromide and oxide of this element, that what will be the formula of these compounds, right? So we can find out this, okay, since valency of the element is given here, right? So look at this, the A part. In the A part, right, we need to find out the formula for the bromide of the element, right? So first we'll write down the valency. Valency of X is 2, right? And what is the valency of bromine? Valency of bromine, as I told you, you have to learn these things, right? Valency of bromine is, you can check out the table, it is 1, minus 1, right? Okay. Now we will write down, so the formula will be, the formula for the compound, right, will be, now X and Br. So first we will write down like this, X and Br, X valency is plus 2, it is given, and bromine is minus 1, right? Now using the crisscross method, right, we can write down the chemical formula for this compound, that is XBr2, right? Okay. So in this way, we can write down the formula for this bromide, the compound of this element, right? XBr2. Is it clear? By the crisscross method. Understood? Now in the same way, you can find out the oxide of the element. So the B1 is oxide of the element, right? So we have to find like what will be the formula for the oxide of this given element, right? So again, we will write down the valencies. Valency of X is already given, that is 2. Okay, valency of oxygen, because for oxide, we know that one of the compound is, one of the element is oxygen. So valency of oxygen is also 2, right? Okay. So what will be the formula? Therefore, the formula of oxide of the element, this will be equal to, right? So we will write down first the types of elements, X and O. X valency is plus 2, oxygen is minus 2. Now using the crisscross method, we can write down the chemical formula. Formula will be, yes, X2, O2, right? By crisscross method, right? Now, since both the valencies are having a common factor 2, both can be simplified form, can be written. So we can simply divide both of them with 2. So we'll get XO. So whether this or this, right? Both are correct, but we generally write it this way when the valencies are having a common factor, right? Okay. So how we can write down the formula of the compound? That is XO, and this is the answer. Is that clear? Yes, sir.